Okay, what is the idea behind cofactor formula? Okay, you navigate for any row or any column. In this case, I am doing by the first row. However, I want to change in the second part. Suppose I take a decision to navigate using this row. We're using row 1 or row 2 or row 3 or column 1, column 2, column 3. The answer, unbelievable, but it doesn't change by the selection of the row. No. Okay, so now I take the first number, que es 1, and multiply by the minor. What is the minor? Minor is a new determinant que es formed when you delete mentally the column and the row associated with this number, que es 1, no? So you mentally are doing this action. I delete this, I delete that. So you delete this and you delete that. We have 3, 5, negative 2 and 0, correct? Okay, now I'm moving to the other guy, que es 4. It's minus 4 because the cofactor have sign. And this sign is determined by the position of the number that you select. In this case, this 1 was located in the row 1, column 1. 1 plus 1 is 2, is even, is positive. However, that 4 is located in the row 1, column 2, is 3, is odd, is negative. That is the reason it's negative. Now, delete this row and this column, stay alive 1, 5, 1, 5, 5, 0, ¿no? Entonces, 1, 5, 5, 0. Finally, es 0. Entonces, si es 0, is nothing. Multiplication by something, I don't care, because si es 0, es obvio que you delete this row and this column and stay 1, 3, 1, 3, 5, negative 2. Pero es obvio que no es necesario to do this. Es 1, 3, 1, 3, 1, 3, 1, 3, 5, negative 2. Okay, not bad. Now the rest is easy because I computed 2 by 2 determinant is super easy. 1 is nothing. 1 is a multiply invisible. I delete that. I erase. And you multiply this times this, positive number, and this time this negative. Y si es negative, it's obvious que the answer of this is 10. Because negative 2 times negative 5 and extra negative when you multiply over is 10. Minus 4 times something. Multiply this and this, que es 0. And multiply this and this, que es 25, pero negative 25. Negative 25. And this guy is here. It's gone. Entonces, the answer is 10 plus 100 is 110. And this is the value associated with this determinant. Okay. Another guy say, well, no, I don't understand very well this. I see you say que you can select any row and any column. There are no reason to select the first one, because suppose que I select that column, and nice, because you have 2 zeros and only one value. Okay, this value is 5. It's 5, but I don't know if it's positive 5 or negative 5. Let me see. This position, the cofactor is located in the row 2 in the column 3. And 3 plus 5, 3 plus 2 is 5, and 5 is odd number, so it's negative. It's negative. Multiplication by the cofactor, by the minor, gets formed when you delete this and this. So you delete mentally this and this, no? Because it's 5, this is this 5. Stay alive only 1, 4, 5, and negative 2. And let's see what happened. You multiply this guy. Okay, negative 2. Remember your multiplication on the downward is positive 1. So it doesn't change the sign, stays the same. And this, yes, this is 20. Negative 20, negative. Multiplication on negative 20. Negative 20, no? Negative 20. Okay, and I forgot multiply by negative 5, no? Okay, it's this negative 5 we have in the front, no? Basically, the red part is the answer for the determinant. And this is 22, negative 22. And negative 22 multiplied by negative 5, negative times negative positive, we get the same answer. Do you see? It's unbelievable. So the selection of the row and column that you select depending on the amount of zeros. So you to simplify your work, obviously you select the row and the combination can have more zero, no? See, you need to do by hand, no? So you need to do by calculator, no? Yes. Let me try to do by calculator. I go to GeoGebra Classic. I suppose you are familiar, okay, with this calculator, this software. Remember the software, I select only the algebra, a cast, it's a cast. The position is not important because you can move. Let's say, let me see if I share well or not. Okay. GeoGebra. Okay, do you see? Yes or no? Answer me.
Yes, yes.
Okay. Suppose that I don't like doing by hand. I want to do using the software. Okay. 1, 3, 5, and 5, negative 2. Think I checking, see I copy well or no. Remember, one stupid mistake, one number can you change, one sign can you change. We are solving completely different answer. No good. Now I select that. Right click and create matrix. Create matrix. Okay, and this is the here is the algebra. You see the matrix. Now here you put determinant. Determinant. I don't finish to type, use the determinant of the matrix N1. N1. I press enter in my keyboard. Bang! 110. Super good. Super good.
Yeah,
Everything okay? Everything okay. Either way, guys, by hand. Do you believe doing by hand determinant 4x4? This is crazy. Super crazy. And 5x5 and so on. In the real life, you have 20 equations, 20 unknown. Okay, this is crazy. That is the reason that the mathematicians are creating that software. That software, no. That procedure and the computer science or the mathematicians together, no, create the software. Okay, now let's move on to the whiteboard again. I want to study in detail the most important property about determinant. So the title of this is property of determinant. Whiteboard. Do you see whiteboard? Okay, we study in detail.
Yeah,
Excellent. Property. Of determinant. Entonces, the classical question, Professor, determinant is a matrix, yes or no? No, it's no matrix. And this is the reason that the symbolic way is different. You know? Determinant is, what's the interpretation there? Determinant is like a function. O sea, a function, when you're studying algebra, function, bam, bam, domain, range. Domain is, you know, collection of the object. In this case, the object for that function is a square matrix. What means square matrix? 2 by 2, 3 by 3, 4 by 4, and so on. Okay? You apply one function que determina que the algorithm I explained, the cofactor formula. Si es 2 by 2 is super easy, it's cross multiply, that's it. And you apply, you associate one number, one real number. Of course, this algorithm is determinant. Okay, determinant, DET. This is the idea for this. Matrix, no. Matrix don't associate any number. Matrix is one object, and you manipulate inside this, and you get the answer. But determinant, no. Determinant is a number. The answer of determinant is a number. That is the reason that the interpretation is a function. Okay, but the property that we study now. Number one, property. Important. The value of an determinant change signs if two row or column are interchanged. It's easy to memorize. And let's see example to understand. Suppose I have, of course, the example I'm doing is easy. It's 2 by 2, hello. 3 by 3 is too long. No good. Suppose this 2, 3, 4, 5. Well, compute the determinant is 10. Multiplication this guy positive, same sign, 10. And multiplication this and this is 12, but minus 12, because I know very well the algorithm will say that when you multiply moving over and change the sign, so you have extra negative, is the idea, no? It's negative. Suppose now, this is clear, understandable. Suppose that I interchange two rows, 4, 5, 2, 3. The thing I did was, this is row 1, this is row 2, and you now row 1, swap, row 2. This is my new row 1, I swap. And multiplication. This is 12, positive 12, positive 12, and this is negative 10. The answer is 2. Do you see? Can change the sign? The original determinant, the answer is negative 2. Now the new one, when you change, the answer is positive 2. And we take advantage of that property to solving the determinant too fast by hand. What about column? No, column is the same. Let me show you. Suppose I interchange two columns. This is 3, 2. This is 5, 4. Okay, what thing I doing? This is column 1, column 2 of the original. But I swap the column. Look, column 1, swap column 2. Now this column gets 2, 4. I put here 2, 4, and this column gets 3, 5. I put here, and you are doing the multiplication. The multiplication here positive 12, and the multiplication here is negative. And the beauty of this is that this is, I prove in one elementary example, 2 by 2. But if you are doing 3 by 3, 4 by 4, the result is the same. It's a property. Do you understand the first property?
Yeah, I think I understand.
Okay. Let's do in the second one. The second property is, well, if all the entry What mean entry? Entry is each element inside the determinant. No column, no row, no element, one number. In any row or column is equal to 0, the value of the determinant. Is also 0. And it's logical. Suppose this determinant 0, 2, 0, 3. Suppose this 1, 2, 3, 0, 0, 0, 4, 5, and 6. I guarantee you 100% that the answer is 0 and 0. Why? Because you take the column number 1 to expand this determinant is 0 times something plus 0 times something. In this case, you take the row 2 to expand that 0 times something. Something is a minor plus 0 times something plus 0 times something is 0. So not necessarily every entry is 0. It's one column or one row is 0. Automatically you see that the answer for the determinant is 0. But not only that, we have more complicated situation. We have more complicated situation. Suppose if in the property number 3, this is property number 2 is elementary. It's obvious, right? Property number 2 is 3 no is not obvious, but I can prove a little bit. Suppose you have 2 rows or column. You see in the determinant language, we're talking about row or column. In the matrix language, no, only talking about row. Row operation, row operation, row operation. Never I explain column operation and matrix. However, in the determinant, yes, we can do both. And no problem. If 2 row or column of a determinant have same entry, or proportional, the value is 0. Again, what mean that? Well, suppose elementary example to understand this. Suppose we have one determinant that 2, 3, 2, 3. Same column, same row. Okay. Okay. The property says that the answer is 0. It's obvious because 2 times 3 is 6, 2 times 3 is 6. So there's 6 in that direction and 6 in that direction. The answer is 0. Professor, and it's always the same? When you have 2? The answer is yes. Because what is the reason? Look, suppose this is an area. Suppose 2, 3, 4, 5, 6, 7, and we have 2, 3, 4. I guarantee you that the answer is this is 0 because this column is equal to this column. But what is the reason? Why? I need to compute to verify. It's always possible. Yes. Okay, one way to understand that this property is true when you have 2 columns or 2 rows the same, is equal to 0 the determinant. Es suppose que es by contradiction. We prove by contradiction. We suppose que no, que es no 0. Es no 0. Entonces, we apply, for example, the property number 1 que we study here. Que the property number 1 say que when the value of the determinant change, so interchange, sorry, 2 row or 2 column, you expect the same value. Suppose que es no 0, es 5, for example. Suppose, hypothetical. Vale. However, to satisfy the rule number one, the property number one, so you interchange. But when you interchange the column 1 and the column 3, es obvio que the determinant stays the same. As you suppose that the answer was 5, the answer would be -5, right? However, no, it's a contradiction because this determinant is exactly the same, this determinant. So I suppose que es the same value, no opposite sign. So what is the only number when you change the sign stay the same? 0. Because 0 have no sign, no? So actually, you prove by contradiction, okay, when you have 2 columns or 2 rows, the answer is 0. I'm not always the same guy. You, for example, you have, for example, proportional. What mean proportional? Suppose this determinant, you have another 2, 5, okay, it's 2, 5, 2. Well, in this case, the same, no? Proportional. What mean proportional? Multiplication by 2. So 4, 10, and 4. And the rest is 3, 6, 3, and 4, 7, 4. It's also 0. So not necessarily equal or proportional. Proportional each other. Okay, no. Suppose que, okay. No, this is obvious. It's 0 because it's the same. No, not good. Not good example. Suppose. You multiply the row number 1 by 2. You multiply the row number 3 by 2 again, or by 5. Entonces es 15, 30, and 15. And you multiply this by 4. Entonces 16, 28, and 16. It's also 0 because it's proportional. Do you understand the idea?
Yeah, I understand the idea.
Okay. Now, suppose property number 4. Property number 4, say. Property number 4. If any row or column, or columns of determinant is multiply by a number, of course non-zero number, another number non-zero number, okay, I want to call K, the value of the determinant is also multiply by K. Okay, maybe a not clear explanation. However, do you see example? The example clarify the idea. Suppose again 2, 3, 4, 5. Let's give it. I did before. This is negative. Yeah, it's 10 positive minus 12. Suppose I multiply by the factor 2. Suppose K equal 2. I multiply the row 1 by 2. Row 1. The new determinant is 4. 2 times 2 is 4. 2 times 3 is 6. And the row 2 stays the same. Let's see what happens with the value of determinant. This is 20. Positive 20. And this is minus 24. The answer is -4. It's twice. It duplicates. Duplicate because the factor is 2. Okay, so the factor is 3, is triple. Suppose another example to clarify more. Suppose now, okay, I multiply the column 1 of the original, is this one, by the factor 3, k equal 3. We have 6 and 12, no? 3 times 2 is 6, 3 times 4 is 12. And the other column, no, stay the same. Let's do it. This is 30. And this is 36, negative. The answer is negative 6, gives the same answer of the original value multiplied by the factor. Okay. This is look like easy, however, no. Because in the matrix happen different situation. In the matrix, when you multiply the matrix times scalar, for example, when you multiply a matrix A times scalar 3, you multiply each entry by 3. Suppose that this is not determinant, it's a matrix. You multiply by 3, 18, 9, 36, and 30. And determinant is different. In determinant, you manipulate by column or by row. Okay, so you multiply only one row or column by a specific number. The value of the determinant is multiplied by that number. This is the property number 4. Okay, I want to explain. Okay, so now normally this property number 4 we are using backward. No multiplication, sino factorization. Suppose que I realize que the column number 1 is divisible by 3, and you factor out that 3 here, and you determine 2, 3, 4, and 5. So I realize que in this column, for example, I see que the great common factor is 3. I factor out 3 outside. And you compute this in determinant again, negative 2. And you compute this determinant again, Caesar is 3 times negative 2, and the answer is negative 6. Okay, same idea, pero backward. Okay, no bad. And let's move on to the property number 5. Property number 5. It's easy. No, it's not easy. It's a little bit complicated. It's about if you. But let me erase the board. I can erase the board. Oh no, I can.
Yeah, you can.
Okay. Property number 5. Okay, property number 5 say. This look like unbelievable, but it's true. If you apply row operations, exactly the same way I do in matrix, no? Remember row operations or column operation. Okay, we never are doing in matrix column no operation, but in determinant, yes, we can do that. The value of that determinant stay the same. Wow, remain unchanged. Doesn't affect the row operation or column operation. Let's see example. Suppose again the classical example is 2, 3, 4, 5. And do it several times, and the answer, remember, is negative 2. No? Suppose I perform that row operation. 2R1 plus R2 storage in R2. Okay, guys, this is, I know that this is at the beginning, student, it's complicated to understand this. But the action is, this is row 1, this is row 2. We create a new determinant in which the row 1 gets this, 2, 3, and multiply by 2, 1 by 1, of course, plus the corresponding value in R2. And this information is stored in row 2. So the only row that changed is row 2, and the row 1 stays the same. Do you see that? Now 2 times 2 is 4, and 4 plus 4 is 8. Do you understand the row operation? So these two is a number. These two is a number. Multiply by this. 2 times 2 is 4, plus the corresponding 4 is 8. Likewise, 2 times 3 is 6, and 6 plus 5 is 11. Now let's see what happened. Surprise. You multiply like that. 22. You multiply like that, negative. 24. The answer, wow, it stays the same. Look, unbelievable. When you perform row operation, let's see what happens when you perform column operation. Okay, suppose again the new one, the original is given 2, 3, 4, 5. And now we are working with the column 1, column 2. And the operation that I propose you now is, for example, 3 times column 1. So I change the factor. The factor is not 2, it's 3. Okay, column 1 plus column 2 stored in column 2. So the new determinant is, well, the only column that change is the column 2. The 3, 5 say goodbye. 2, 4 no, stay. Manipulate, participate in the operation, but doesn't change because this arrow indicate that the information is stored in 2. And multiply 3 times 1, okay, 6, plus 3 is 9. You see where come from this 9? 3 times 2 is 6, plus 3, que es column 2, and 9. And this new number gets 9, not 3. 3 place 3. 3 times 4 is 12. And 12 plus 5, 17. Let's do in that operation. This is 34 plus. And this is 36 negative. The answer again is negative. Unbelievable. So when you perform row operations, the value of the determinant doesn't change. This is super useful to simplification. Any questions so far? Entonces we have another, special cases. Not exactly property, special cases. Okay, special is when you have, for example, a special determinant. Special cases. Suppose this determinant. Two, 0, 0, 3. Es obvio que the answer is 6, no? 2 times 3 is 6. 0 times 0 is 0. And this idea, so that kind of matrix is called diagonal matrix. Because we have only value in the main diagonal. Suppose one more complicated. 2, 3, 4, and the rest is 0. This is also diagonal matrix. Because we have only number in the main diagonal. And when the situation happens, the answer is multiplication only the main diagonal. 2 times 3 is 6, 24. Unbelievable. Okay, it doesn't matter again. We have 100 row and 100 column. No, you multiply only the main diagonal when it's diagonal matrix, no especially. But not necessarily perfect diagonal. We have upper diagonal or lower diagonal. Suppose this is scenario. Suppose 2, 3, 4. And this is 0, 0, 0. But this is not 0, it's a number. 5, 6, 7. Or this is scenario 2, 3, 4. And this is another number 6, 5, 6, 7. And this is 0, 0, 0. It's also 24, guys. Independent, see it's below or above. I don't care, that number don't participate in the computation day. To prove this is a little bit complicated, no? But I accept like a special case. Let's apply. I bring a couple. Yeah, a couple. No, 3 examples about the application for the property. Okay, I want to show you. And the review package, we have more. No, we have only 2 in the review package. And the student never understand this part. The majority of the students never understand this part. Don't answer that question on the test. I don't know why. It's easy. Example 1. Suppose it's given one determinant. And unfortunately, we cannot using software because it's a letter. In the numerical, yes, but in the software, no. This is -4. This is given this information. I want to find compute. This one gets similar, no? Is X, Y, Z, UBW, and 2, 4, and 6. Question mark. Using the property. Well, there are many ways to do that. One way is maybe you try to apply the property not in the original, no, in the new one. Okay, you need to compute and try to manipulate. It look like similar or not similar, identical to the given information. As I saw, wow. I applied the property number 4, I guess so, no? Number 4, I don't remember very well the number. Property number, yes, number 4. Okay, is the property that allows us, when you discover a common factor, 2, 4, 6. Okay, the great common factor between 2, 4, 6 is 2, no? You factor out 2. 1, 2, 3. Wow, exactly. I need 1, 2, 3, 1, 2, 3, 1, 2, 3. This is similar to this 1, 2, 3, UBW and XYZ. To do another operation, another property, okay, these look like equal to this. You interchange. You interchange what? You interchange, for example, you swap row 1 and row 2, row 3, no? Row 3, look, swap. So says 2, don't forget that 2, okay, what's the common factor here? When you swap and you put 1, 2, 3, and you put here X, Y, Z, and this stay UBW, no? Because I don't touch never UBW, no? And when you swap that, I know, okay, you need to change the sign. So it's opposite sign. But I know, because given, okay, this determinant is -4. Therefore, -2 times -4 is positive. And the answer is positive. Do you understand this or no?
Yes.
So basically, the thing I am doing is apply the property number 4, but backward, I realize that the great common factor is 2. I factor out, no? Okay, no problem. The property number 4 say that when you multiply one determinant by the number, you can multiply any column or any row. In this case, es the column 3, ¿no? Okay, entonces these two I put outside, you multiply by the row 3, stay back to the original 2, 4, 6. But I do I factorization. Now I see, wow, this look like similar to the original, but no. I need to swap two rows. When you swap, you change the sign. The answer is -4 and -2. Entonces -2 times -4 is the information is given at the beginning, is positive. The answer of this determinant is positive. This one. This one is positive. Clear or confusing?
Clear.
Of course, you need to use in the imagination, no? And common sense. Okay. One more. Suppose this, example 2 of the property. Suppose one determinant is given, 1, 2, 3. X minus 3, Y minus 6, C minus 9. And 2U, 2B, 2W. Okay, I forgot to say something. The given is the same of the sample 1. 1, 2, 3, UBW, and XYZ is -4. At least the first row is identical. I can see que 2 is a common factor here. Why no? Out. UBW. Now I need to eliminate somehow 3, 6, and 9. Well, I suppose que we apply row operation. Suppose que you multiply by 3, row 1, plus row 2, and storage and row 2. When you multiply by 3, 3 times 1 is 3, plus this, positive 3 and negative 3 is cancelled. And the second is 3 times 2 is 6, positive 6 and negative 6 is cancelled. And the last one is 3 times 3 is 9, and positive 9 and negative 9 is cancelled. And when you store that information in the row 2, after perform this row operation, this stays the same, this no, this change, and this stays the same. Do you see the transformation? Do you see? And you know that when you perform row operation or column operation, the value of the determinant stays the same, so it doesn't change. No extra factor, no nothing. Now finally, interchange the row 2 and row 2, swap row 3, no? In this one. So we have 2 times, but actually no 2, it's -2, because when you swap, it says 1, 2, 3 stay the same, UBW and XYZ. At that moment, I compare this determinant is exactly the same at the new one that is given at the beginning, and -4. And the answer is -2 times -4 is +8 again. Good. Do you get the idea?
Yes.
One more example or no? Enough. One more.
Yeah, one more.
Yeah.
Okay, suppose this. X plus 3, Y plus 6, C plus 9, 3U minus 1, 3b minus 2, 3w minus 3, 1, 2, 3. Compute that. Again, this is the given. Entonces, I suppose que es better, in my mind, in my opinion, manipulate not the original, sino manipulate the more complicated, because we have more degree of freedom, no, to manipulate. Entonces, okay. Entonces now I propose you, for example, row 3 plus row 2, row 3 plus row 2. This is the imagination, guy. Store and row 2. So row 1 stays the same. I don't touch for a moment. Row 1. Row 2 change, and row 3 no. Participate, but don't change. If you multiply, you adding, row 3 and row 2. Es obvio que positive 1 and negative 1, positive 2 and negative 2 cancel, entonces stay 3u, 3b, and 3w. Make sense or no? You see, wow, this guy I don't like. I need to eliminate. How you eliminate? Well, you're adding the row 2 plus row 3 and the new information you store in row 2. Okay, not bad. Now I can see clear like water a common factor, que es 3. I factor out. Look, 3 out, and we have x plus 3, y plus 6, c plus 9, ubw, and 1, 2, 3. Bueno, okay, I understand, but I need to remove somehow this 3, this 6, and this 9. How you are doing that? Well, a multiplication by 3 or by negative 3. Row 3, que es this, plus row 1, and store this new information in the row 1. When you are doing this action, let's see what happens. Don't forget that trick is important. 3. The only row that change is the row 1. Row 2, row 3, no. Stay the same. When you multiply negative 3 times 1 is negative 3 plus this 3 is cancelled with this. Entonces x. When you multiply again, negative 3 times 2 is negative 6 plus 6 is y. Likewise, s. And this determinant, let me compare with the original. Look like similar, but no. We need to swap. Row 1 and row 3. Swap row 1, swap row 3. Yeah, I know that when you swap, you change the sign. It's negative 3. Now it's 1, 2, 3, ubw, and xyz. I know very well that the answer of this is negative 4. And negative 4 times negative 3 is positive 12. That's the answer. Get the idea? Get the idea?
Yeah.
Okay. Now, fantastic application of the determinant is when you know a little bit about determinant property, something. Now you apply. There are several applications, but the most important application we study here is solution for the system of equation. Let me start for elementary problem, because I am using one rule that's called Kramer rule. Kramer rule. It's the fantastic way for solving the system. Some people lie that way. Okay, suppose x plus y equal 8, equation 1. I explain elementary example to introduce the idea. And x minus y is equal 4. Wow, professor, this is too easy, do it by hand. Because, for example, you adding equation 1 plus equation 2, no determinant, no matrix, no nothing, and you have 2x equal 12, no? 2x, this is canceled, ready for elimination. This is 12, x is 6. Now plugging in, for example, in 6, es obvio que y es 2. I know that this is the answer. I want to explain now the new rule. Kramer rule. And we can apply this rule for system super complicated que contain 4 equations, 4 unknown, 5 equations, 5 unknown, and so on. Look, you compute the one thing first. Let's call it D, capital D. Capital D. What is the capital D? D. The capital D is the determinant of the system, que es only the coefficients in front of the variable. 1, 1, 1, negative 1. And you forgot A and 4 for a moment. Let's do it. 1 times negative 1 is negative 1. So this is, remember, you multiply this and this, don't change the sign, and here, yes. Es negative 1, entonces negative 1, another negative 1, es negative 2. But D is negative 2. Okay. And we're using after that. Now compute dx. What is dx? It's the same determinant, but you now replace the column of the x, que es this, by the right hand side, A4, and this stays the same. So you see the column of the x replaced by the right hand side. And the column of the y, no, it stays the same. This is dx. This is negative 8, and this is negative 4. It's negative 12. And dy is, again, the column, the first column stays the same, 1, 1, and the column of the y replaced by a and 4. And now multiplication. 1 times 4 is 4. Minus 8, remember, when you move it in that direction is negative, when you move in that direction is positive. This is super easy and 2 by 2. The answer is negative 4. Okay, now the crucial moment. Crucial moment of the Kramer rule. X is always division dx divided by d. Who is dx? Is negative 12. Divided by negative 2 is positive 6. Exactly, we predict here. Look. And y is dy divided by d. Is then negative 4 divided by negative 2 is positive 2. Exactly the solution that we predict at the beginning, because I put the elementary example to illustrate the idea. Okay. So you see, one professor, in this case, it's obvious that by hand, no necessarily Kramer rule, no, but in all more complicated, I want to illustrate right now, it's obvious that we cannot do it in this way. This is more organized, a systematic way to solving any system. Okay, it's obvious to understand in this case, you need determinant system. You have 3 equations, 3 unknown, 4 equations, 4 unknown, 5 equations, 5 unknown, determinant. No under ni over determinant, no. Under and over, when you use a reduced echelon form, get the first procedure that we study. In this case, no. When you make a decision to work with the determinant, you're working only with the square matrix, 3 by 3, 4 by 4, 2 by 2, etc. Okay, let's move into the last example in which I want to illustrate one system 3 by 3. Of course, we're solving and by hand, no, using the software. Okay, let's do it. I can erase the board. Yes. Okay, suppose that system x plus y plus c equal 6. Equation 1. 3x minus 2y plus c equal negative 5. Equation 2. X plus 3y minus 2c equal 14. Equation 3. This is my system it's given at the beginning. And we know 3 different ways to well, and the other chart that we are doing by hand, select to copy equation. No. But now the systematic way we study reduced echelon form, we study inverse matrix formula, and we study determinant. We are using Kramer rule for solving this. So you compute D. Who is D? Well, D is the determinant format by coefficient get 1, 1, 1, 1. Sorry, I make a mistake. You see, I make a mistake one sign. The answer is totally different. This is -1 here. -1. Okay. This is 3, -2, 1. And this is 1, 3, -2. Let me check and see. Yeah. Okay. Of course, we can do by hand here, but no. I go to GeoGebra. So in the paper, I organize the word. I want to explain how you organize in GeoGebra. Who is the x? Well, the x is equal the column of the x replaced by the right-hand side. And the other stay the same. 1, -2, 3, -1, 1, -2. This is dx. And give me one answer. dy is the column of the y. So this stays the same. Look, the column of the y now is 6, -5, 14, sorry. And the other is -1, 1, and -2. Okay. And this z, because we have 3 variables, is 1, 3, 1, 1, -2, 3, and 6, -5, and 14. Do you understand this organization? So basically, I take D, que is the most important guys in Kramer rule, que is only the determinant formed by coefficients in front of the variable x, y, and z. I don't care right-hand side. Now the right-hand side is a vector you replace by the corresponding column. Column of the x, column of the y, or column of the z. Clear or no? Clear or no?
Clear.
Now I go to GeoGebra to compute that super fast. I come back after to the whiteboard and we finish the job. Let's do it. GeoGebra. Okay. And let me know. Switching to GeoGebra. Okay. Okay. Yeah. Do you see GeoGebra? Yes or no? Do you see or no? Okay. Now I want to delete that. I want to delete that. Delete. I select. I delete. Okay, super. I type in my original problem. S1, S1, is -1. S3 is -2. If you see some mistake, let me know. S1. 1, 3, and -2. Okay, not bad. And here, a little bit close in the same row, I copy the right-hand side, okay, 6, 25, and 14. Okay. And you copy that. Control C, right click, copy. And one this time you paste. And you replace this guy. Copy by this column. Paste. Good. I like that. Again, I should copy 2 times, 3 times. Copy, copy, copy. Paste, paste, paste. This is dx, this is dy. And maybe this is dc. And you now copy that. Copy, and paste here. And that column, que es the Y column. Or paste here, que es the C column. Boom, perfect. Now let's do them step by step. You select the original determinant, capital D. Create a matrix. Yeah, I prefer in this case rename. I right click in the name, rename equal capital D. Capital D. Boom. Okay. Now it's doing exactly the same. Copy that. Create a matrix. I want to call this matrix dx. I use in capital in both. Okay, I say okay. Now I select this. It's too long process, guys. But it's better than by hand, no? Select matrix, rename dy. dy. Okay. Finally, C. Rename. Help me to organize. dy. dc, sorry. dc. Okay, ready. I come back to the computer assistant software. Get that part. I compute determinant of D. Capital D. Boom. Enter. The answer is -3. Okay. Now again, determinant of dx. Answer is -3. Wow. That means que x is equal to 1, no? Because the formula for the increment say que dx divided by d. Okay, super. Determinant now of dy. The answer is -9. Wow, entonces -9 divided by -3 is +3. Okay, it's a y value. And determinant of dz is +6. The answer for the z is 6 divided by -3 is -2. Okay, do you understand this? Yes or no?
Yes.
Okay, let's move on to the whiteboard to finish that problem and organize the solution. No? And the whiteboard, I can see, look. Whiteboard. The answer I get in the software was -3 here. That was -3 again, coincidence. That was -9. And that was +6. Therefore, x is equal division dx divided by d. Es -3 divided by -3 is +1. Y value is dy divided by d. Entonces es -9 divided by -3 is +3. And z is dc divided by d. dc is 6, d is -3, the answer is negative. Therefore, we have only one solution, unique solution, and the solution is located at the triple order x, y, z. In our specific example is 1, 3, positive, negative. End the story. Do you understand this or no? Super clear?
Clear.
Okay. So now it's important. Let me spend this few minutes to finish because I don't want to do anymore. It's basically in this chapter we study again linear system of equation. This is important, right? And we study number one, the reduced row echelon. This is the first approach form. The second one is inverse symmetry. But let me say something more. In the echelon, we found the augmented matrix, separated by line. This A is that matrix, so this is A, and B is this. And you put together like only one matrix. This is called augmenting. And you apply the algorithm of reduced row echelon and algebra, of course. And inverse symmetry, no. In the inverse symmetry, you manipulate with the square matrix. You find the A matrix, it's the same A, but you find the inverse. A multiplication by B. And you get the vector, and the vector give me three numbers, 1, 2, 3, or 4, depending the amount of equation, give me the solution X, Y, Z. And this is numerical value, no? And 3 is determinant. Kramer rule. X is equal to dx divided by d, y is equal to dy divided by d, and c is equal to dc divided by d. And that's it. Kramer rule. Either way, what do you like more, in your opinion? Number one, number two, number three? I know what is your answer, because every semester I teach in this part, the student answers similar.
I think the first.
The first, okay. Another opinion? Come on, guy. Say number one, number two, I like, or I don't like anything. I feel horrible in this chapter. How do you feel in this chapter? Good or no?
It's a bit hard, but it's easy to understand.
You know, behind this, there are a lot of operations. Que si you try to do by hand, it's impossible or crazy. Okay, so this is not the challenge. The challenge is not the arithmetic, because using the software, we solve that, right? The thing is the organization, how you organize and how you interpret. How you interpret the answer, right? Entonces, one student say que number one. No one like another way. 2 no, and 3 no. Nobody. Come on, opinion. One student only one. And the rest.
The same one.
The same one, okay. And the other student, come on, opinion, come on. 5 minutes we have. Are you sleeping? Antonio de Armas. Micro, Salavarria, opinion. Anthony Suarez, opinion. Rolando Izquierdo, opinion. Are you sleeping? Stephanie Ramos. Okay, what is your opinion?
It's a
one, okay. When I ask you why, you say no, maybe because I understand better, no? Or it's not too long, or I don't know. Maria Padrón, opinion. Yesaya, Anthony, you see me, Reynoso. You say me, are you there or no? Or you are sleeping? You say me?
Yes, I'm here.
Okay. Opinion, what is your opinion? Diana Marina. Uniel Garcias, Claudia. Are you shy? You don't want to express your opinion? Okay. I am coincidence with you. Different to another class. Another class, some people say, no, Kramer, I like Kramer. Kramer is mechanical. I got it. Advantage and disadvantage. Suppose que D is 0. Que sometimes happen. Que D is 0. So we cannot divide it by 0. So it's impossible. It's no application Kramer rule. However, we have solutions when the D is 0. Remember, in the system, we have 3 possibilities. one solution, que is the most common case, no solution, and infinity many solutions. And echelon give me exactly the information when it's infinity many solution, how many free variables we have. In my opinion, it's the most complete method. However, we have another. Okay, guys. So stop. Next time, 30, we start review. Okay, review for the test. Are you clear?
Yes.
Don't see the syllable, because I suppose I change the syllable, no? When the test is due, you don't worry, you only pay attention, you are here with me and only pay attention. When I finish the review, is the moment to take the test. What test? Online and on paper. And online, don't worry, because I changed the due date. Okay? Okay?
So do they for Alex to be changed?
Yeah, I change. I will change your moment. No.
Okay.
You don't worry. You only pay attention and try to understand. Another question?
And the homework is gonna be changed too on Alex?
Yeah. I change everything. I change homework and change the test.
Okay.
Yeah.
Thank you, Professor.
Thank you, Professor.
Okay, bye-bye, guys.
Have a good day, Professor.
Have a nice day.